All right. So good morning, everyone. Kindly confirm if you're able to hear me out well.
Good morning, sir. Yes, sir.
All right. And all of you can see my screens.
Yes, sir.
Okay. So good morning once again, guys, and I welcome you uh, to this lecture. Uh, yes, in the last class, we were discussing about the infrastructure as a service more in details. We saw a lot of good details about launching the virtual machine, which was pretty important for all of us to understand the infrastructure as a service more in the details. And with that, we went into quite a lot of depth around EC2 pricing models, EC2, metadata, and then what is the importance of the IP address and all that stuff. In the today's class, we would wrap this up by discussing about the storage part. It's not like that we have not touched the storage earlier, but we have discussed about the storage earlier as well when we talked about EC2. But here we shall be talking more about the EBS, S3, EFS, and Glacier kind of things. Okay. All right. So in our previous class, we talked about the object storage and the block storage. So what is the main difference between these two? Can anybody explain what is the main difference between object storage and the block storage? Or maybe you can just raise your hands if you are clear about it or you're not clear about it. Mhm. Okay, so nobody knows about it. Okay, no problem. So, so what happens is, guys, when we are talking about uh, so object storage, basically we are talking about storing the data as the form of the objects, where each object basically contains the data about itself. For example, imagine that, guys, you have a photograph or you have a PDF file, or suppose that you have a file which is basically very big in size, something like you have a log file. Okay, so along with that, imagine that you have the metadata of that file, for example, like the owner, creation date, content type, etc. And then you have the unique identifier, like for example, what is the ID, what is the key. So there are basically this is like a full object. This is the full data along with the metadata. That is what we call as object storage. Now, guys, whenever the object storage comes into the play, the one thing that should come to your mind is the AWS. In the AWS world, S3 is the one simple storage service which provides you the object storage service. Similarly, in the Azure, we have the Azure Blob Storage, which is like just the object storage representation. Then in the Google Cloud, we have the Google Cloud Storage, GCS, where particular object can be uploaded. Now, for example, if you upload a file, maybe say suppose that you have some invoicing .pdf, then if you are uploading that to the Azure Blob Storage, then it would become an object by itself with the metadata. And its metadata would be like its owner is Aditya, or maybe the type is PDF, size is maybe 10 GB or whatever. And every object on the cloud would have its accessibility by the URL. So you would have something uh, the URL blog.windows.net/container/invoice.pdf or whatever like, right? So you can interact via the REST APIs. My point that I'm trying to mention about the URLs is that you can interact with the object storage, the objects present in the object storage using the RESTful APIs or the SDKs as well. In the SDKs, you have the so I hope you understand. So what I'm trying to say is that you have this uh, objects which can be uploaded there, and every object would have its metadata like owner, etc., as I mentioned to you, and they can be accessed by the RESTful APIs or the SDKs also. Now, when do we use the object storage? We should use the object storage. Guys, I'm talking about the object storage, okay? Don't get confused. So object storage I'm talking about. Whenever we have to deal with a large unstructured data, that's where we wanted to interact and work with the object storage. Okay, here it is the responsibility of both the users and AWS to keep the data in the replicated format. So basically, it spread the data across the multiple nodes for the redundancy purpose, and therefore it is very good for the large and unstructured data. Okay, now let's talk about the block storage. So guys, what happens in the block storage is it breaks the data into the fixed size blocks. For example, 512 bytes, then these are the blocks of the data into which the data is being breaked. The block storage breaks the data basically, okay? The block size can be 512 bytes, or it can be 4 kilobytes or whatever not. And then it stores each block with the unique address. So, for example, like in the case of the AWS, we have the block storage in the form of EBS, Elastic Block Storage. In the case of the Azure, you have Azure Disk Storage, right? So whenever you launch in virtual machine, that is what we saw in the just next last lecture. Whenever you spawn up an virtual machine, you would attach the managed disk, right? That is nothing but, guys, the block storage. So what happens as soon as you attach the block storage with the virtual machine that you are spinning up, your operating system, the one that you have chosen, would format it with NTFS or whatever like the file system that is being applicable, and it would be used as a simple local drive. Okay, so please note that whenever I'm talking about the block storage, it is directly attached to the computing instance, which is virtual machine or the container or the host, and the data is being divided into the form of the blocks. Now, the block can be accessed independently also. Okay, so that is the main difference. In the case of the object, you would be storing the direct object, whereas in the case of the block storage, you would be dividing the data into the form of the fixed size blocks, and then you would be storing them up. Block storage is mounted via the file system on the operating system, whereas object storage can be accessed via the HTTP APIs or the SDKs also. When you talk about the speed, of course, since block storage is the blocks level and each block can be also accessed independently, therefore, the speed is higher in the case of the block storage as compared to the object storage. Okay, and whenever you have to spin up like operating system disk or some databases, then you would use the block storage. Whereas you want to store some log file, some media file, some backup files, then you would be using the S3. That is the object storage. Okay. So consider guys like the object storage is like your very big or very massive digital warehouse where you have millions of objects and you can then search by the label or the ID from them. Whereas in the case of the block storage, you have a hard drive which is divided into the various blocks and the data is very fast to be accessed from here. I hope this is clear. This is the main understanding between the object storage versus the block storage. The one thing that I would like to add for your understanding, in the case of the block storage, if at all you change even one single character in a 1 GB huge file, then in the block storage, only those blocks which contains that particular character would needs to be changed. Only that block needs to be changed whenever, whereas when it comes to object storage, the whole file would be updated. That's how the object storage is being built. So therefore, all of these factors that I talked about would bring in the difference in the throughput, efficiency, cost as well. Okay. Why? Because in the block storage, as I mentioned, it is a very small change. But here in the object storage, it is a whole file change as such. So therefore, block storage is obviously faster and it uses less bandwidth because change is very minimal here and it costs more as well when we compare it to the object storage cost because of its present efficiencies by design. All right, we will now discuss about the EBS. As I mentioned to you, EBS is designed to be durable to the extent of 11 nines after 99. So it is a detachable block level storage. So this is attached directly to the instance as such because it provides very low latency. Okay. So what can you do with this? You can perform the backup on this EBS. Basically, that is termed as snapshotting. Very first snapshot is called as the baseline snapshot. And the next one, then you only have the difference from the previous one. Okay. So you have the use cases which are present over here. So it is a boot volume storage for instances, right? You can have the data storage. You can have the database hosts. Applications can be installed. That is about the EBS. Now, there are two types of the EBS volumes which are available today. For example, you can go with SSD or HDD. SSD is provisioned for the general purpose as well as I/O, whereas HDD is the throughput optimized and cold type as well. The maximum size for all of this is 16 terabytes. And maximum IUPS that is like, for example, the maximum input output per volume is also stated over here. In case of the hard disk HDD, if you look into the hard disk, because it is magnetic in nature, there are some restrictions. And that's why the max IUPS is 500 and 250 in the case of the throughput optimized and cold type of HDD respectively. Okay. Maximum throughput per volume is also being stated over here. So that is how the maximum throughput per volume is also applicable over there. So now let us look into the use case of the EBS type of volumes. We have the general purpose SSD. Most of the workload actually works well. It accesses the boot volumes and we have virtual desktops for applications which require low latency because it is directly attached to the instance. And it is working with the SSDs. Therefore, it would have low latency. When we look into the provisioned IUPS, here we are talking about basically we are talking about maybe let's talk about some specific critical application. For example, you have like financial transactions, right? So that is a provisioned IOPS. The next one is the throughput optimized, which is for the big data applications, like for example, processing the log, or it could be used for that, you know. But please note, it cannot be used for the boot volumes. Similarly, the code also cannot be used for the boot volumes. Okay. Are there any doubts so far, guys?
Hi, sir. Sorry to interrupt. Sir, could you please explain that provisioned IOPS and throughput optimized difference?
Sure. So, okay, tell me first of all, what is that you have understood between SSD and HDD? What is your current understanding? What is that you have understood? Hello?
Yes, sir.
What is that you have understood? Maybe just maybe one liner. Can you just summarize what is your understanding so far?
I didn't get it clearly, sir.
Okay, okay, no problem. See, when I'm talking about the EBS, first of all, you would have to understand. Uh, so EBS is providing you the block storage volume. This is clear so far?
Yes, sir.
Okay. Now, each EBS volume is behaving like your virtual hard drive that you have attached to the EC2 instance. And of course, as I mentioned, you can replicate it with you can basically format it with any file system like NTFS or ext4, etc. Now, what I'm trying to explain over here is that with EBS, you have the SSD versus HDD. So, in the case of the EBS SSD, what I'm talking is it is the this one basically the solid state drives, they are being optimized for the high performance. Whenever I talk about high performance, I mean I need high IUPS. What is IUPS? It is input output operations per second. So I need very high. When I say very high, if I have to quantify, it means up to maybe 256,000 IUPS. This is the block kind of access that I'm talking about. When I say throughput optimized, it means it is low cost and optimized for the large sequential workloads. I can have performance up to 256,000 IOPS, or you can say maybe like in terms of MBs, you can say 500 megabyte throughput. So if you have like very big data, maybe like for example, the stream of the logs coming in, then you can use the SSD with the EBS volume so that you can make it throughput optimized. That's what I meant by provisioned IOPS. Is it clear?
Yes, sir. Thank you.
Okay. Okay. Now let's talk about one example. Okay. This example is for everyone. So guys, imagine that you have like, let's take practical example to understand this further better. Guys, imagine, and I expect the answer to be from everyone. Okay. Everyone, please raise your hands and or maybe please put the answers into the chat window. Guys, imagine that you have a database. Imagine that you have a MySQL database. It has 1 terabyte of the storage, and imagine that it is configured for 20,000 IUPS. So you can understand it is low latency and high durability kind of system that you would like, right? So now tell me what would be what would be, you know, the most pressing needs that we would go with this kind of arrangement. So I repeat my question. We have a database, which is like MySQL database, which requires 1 TB of storage, 20,000 IOPS, and the low latency requirement is there. Okay. So why is that? What is the pressing need? Why would you go with this kind of configuration? That is the simple question. Whatever comes to your mind, please write in the chat windows. For what purpose would somebody go with the database of 20,000 IOPS and 1 TB of storage? That is the question. Okay. I want answers from everyone. Guys, please participate. Okay. Very good answers. Please continue. Yes. So you're right, guys, everyone. So we would go with this kind of arrangement because we would like to have the predictable and consistent performance, which is very critical for the OLTP workloads. So answers from all of you are absolutely right. Yes, this is the primary need that we would go ahead with this kind of arrangement. And again, this is coming from the block storage. That's why I would go with, that's why I was explaining, we go with the provisioned, high provisioned IUPS because this is high, right? 20,000 IUPS I'm talking about. So it means that we are going ahead with such a huge number of IUPS for the consistent low latency performance. Okay. Okay. So now let's look at the features that we have in the EBS. Guys, as I already mentioned to you earlier, the snapshots can be taken over here. And using the snapshots, I can create the new volumes. I can provide encryption at no additional cost. I can even scale them and change their type as well. So what are the storage options which are available for the EC2? EBS is of course there, which we have discussed. Instance store is also there, which we have discussed. But apart from that, we should also know that there exists an EFS, that is Elastic File Store, that can also be used as a storage, and S3 can be also be added as a storage. But what you need to know is that you cannot have them as the root volume. Root volume should only come from either instance store or EBS. Okay. So here basically we talked about volumes. Volumes persists independent of instances, and they are charged by the amount of the space which you use for the space that has been provisioned for the month. Okay. When it comes to the IUPS, that is input output per second, when it is general purpose, there you get charged by the amount of provisioning in the GB per month. For magnetic, it is being charged on the basis of number of requests per month. So these are certain facts which I'm trying to mention over here, people, about the EBS Amazon, Amazon EBS. Moving to the snapshots, Guys, I can create the snapshots and I can store it into the S3. When I store it into the S3, then the storage cost of S3 would apply. Snapshot by themselves would not get charged at anything. Inbound data transfer is free, whereas outbound data transfer across the regions incur the charges. If it is in the same region, they do not get charged. Please note that. So inbound data transfer, I repeat, is free. Anything that you put inside is free, whereas whenever you take anything out or access it, that would be considered under the category of the outbound data transfer across the regions. That would occur you the charges. But if you're doing in the same region, it will not get charged. Now, guys, moving to the Amazon simple storage service, which is S3, which is an object storage. It is and being managed solution in the cloud, which is designed for the scalability purpose. Here you can read the objects, write the objects, and delete the objects also. So here you have basically a bucket, whereas in the case of the Azure, you have the container where you end up storing the objects. Bucket is just a logical unit of storage which separates the scope of other objects being stored into the S3. Bucket name should be unique across the whole S3. As we discussed in our previous class, this is unique across the whole simple storage service. Similarly, the same concept is applicable in the Azure as we saw in the demo also. So far as the limits of the S3 is concerned, the maximum size of the object that can be stored here is of 5 terabytes. Okay. And as I said, this is durable to the levels of 11 nines after 99. And you can also set up the policies in order to provide very granular access to the object level as well. Okay. So how do you upload the data to the S3? That is the question. The first and foremost, we have to create a bucket in an AWS region. And I can upload anything that I want. Guys, there are two ways through which I can access them. One is called as the bucket path style URL, where you have S3 as a service followed by the region and followed by the bucket name. Then you have the bucket virtual hosted style URL, where you have the bucket name, which belongs to the S3 service followed by the region name. By default, whatever you store in the S3, for example, you see here one MP4 file is being stored. The same is being replicated across the 3 different facilities. Okay, that's the reason it is very durable in the nature. So that's how, guys, you upload some data to the S3 bucket. Now, guys, how do you access to the S3? There are 3 ways. That is, we can access a object which is present into the S3 using AWS. First number is using AWS Management Console. You can just go to the dashboard and access the file, or you can use the CLI, or you can use the SDK also. And some of the common use cases for the S3, as I mentioned, you can store the log files, which is very big data. You can also use the S3 for hosting a static website. Okay, so you can host a static website from the S3. And of course, you can backup and recover the data as well as a part of the disaster recovery. If you do not have any transactional data, the most of it is being kept into the S3 buckets. How about pricing? This pricing is based upon pay only for what you use as the utility model. This pricing is in the GBs per month. We have to pay when we transfer out to other regions. And if you have requested for RESTful operations like put, copy, post, list, get, etc., then you would be charged as well. When is that we shall not be charged? When we transfer inside to the S3, meaning we are giving some data to the S3 bucket, then we are not charged. That is when we are uploading something, we are not recharged. When we transfer from the S3 to the other services like CloudFront or EC2 in the same region, then we shall also not be charged, as I mentioned. But to the other region, it would be charged. There are very fine level granular details that I'm talking about. I'll take a quick pause to check if you have any questions or any concerns or any thoughts here.
Sir, in object storage, we mostly, I mean, the unstructured data is allowed, right, to store.
So you
I mean,
can,
something
yes.
media files like that.
Uh-huh. Yeah. Yes. What is the question?
That's what I want to understand. Actually, a little bit still confusion I have in between this object storage and the block storage.
Sure. So see, as I explained to you very clearly earlier, in S3, you can upload a full file. So basically, uh, you can upload an object, but just you mentioned unstructured data. You're right. You can upload the unstructured data like image, video, a backup file, a log file, etc. But you can also upload a semi-structured data. For example, you have the JSON file, you have the XML file, you have a CSV Parquet file that can also be uploaded as an object. And you can also upload the structured data as I just mentioned. For example, you have the database snapshot, you have the query
Mm-hmm.
results, you have the database backups. For example, in the form of the files, you
Okay.
can store the data.csv, you can store the backup.sql. So you're right, the S3 is most commonly used for the unstructured data, but you can also store structured and semi-structured data also as long as the data is being saved into the file or object. Now, why it is really called as unstructured storage? Sometimes you would hear that people are calling S3 as unstructured because there is no fixed schema. The relational queries cannot be fired over there. Like for example, we can fire a query on the SQL database. You cannot do that on the S3. The data in the S3 is being stored in the form of the key value format. You upload the key and then you have the value as the binary file content or something like that. It does not care about the type of the file or the format of the file. It just stores them as an object and the metadata. That's all. So now, for example, if you're building some data lake, then you would like to store the data into the S3. For example, imagine that you have lot of big sensor data, raw logs data, CSV data, right? You would be uploading them to the data lake. So in order to form a data lake, you would upload them to the S3, sorry. You want to perform some ML training of your model, then you would use the data sets to be stored at S3. You want to store some backup of your data store, then you would be using the S3. You want to host a static website like static HTML, static CSS, JSS, you would be using S3. You would be using the S3 for all lot of these purposes also. Now, there is another one product called as Athena or the glue, where you can query the data later after you are uploaded to the S3. That is majorly for the analytics purpose. Okay, does that make sense?
Yes.
Is it clear now?
Yes. Yes. Exactly.
Okay, so
Sir, I have a question here.
one second, one second. So
Okay.
Yeah. So guys, I have this is my blog series. So you can just have a look at it. I have written some blogs for AWS, Athena, the data lake, which you can use on build on the top of the S3. So you can study about it. Uh, the part number I have deep dive into S3 for devs. You can go about S3 and then you can study about the part 6 and part 5, which talks about the data lake, Athena, etc. etc. I hope this would be helpful. Yeah, please go ahead. Next question.
Sir, as we see that S3s are chargeable as per the GBs per month, right? Suppose our data is of 2 TB, and as in the earlier slide, we can see that the maximum size we can store it in the object as a object is 5 TB. So, can you please relate to this because we are using only 2 TBs and that object can be stored maximum size is the 5 TB. How it will be charging pricing of that scenario?
Okay, okay. So you have understood. Uh, you have understood it very well. So the data of the 2 TB, if for example you have one big log file which is of 2 TB, and uh, you have uploaded it. Okay. Now what I mentioned is that there is no charges while you upload the file to the S3. Clear? So far, is it clear?
Yes, sir. That is clear.
So imagine that you're uploading some file. Now that file is stored, would be stored in the S3, right? Correct? That
Yes.
file would be stored.
Yes.
So there would be some charges that would be applicable for the storage, basically. The maximum size of a single upload, basically, I'm talking about a single put request is 5 GB. That's what I'm trying to say. Now, if you upload larger files than this, you would have to do a multi-part upload file. That is also possible. Now, of course, for the 2 TB file also, you should use the multi-part upload only, because then that is the best approach, because you would be able to split the object into multiple smaller parts, and you would have multiple chunks over there. Now, S3 is splitting the large file into the parts, and it is uploading in parallel all the parts. If one part fails, you can only retry that particular part, not the entire 2 TB file. Now, coming toward the charges, whatever you are uploading, there would be no charge, as I mentioned. But whatever you are storing the data using the storage, you would be charged. So for example, now one thing that I would like to mention here is that the storage is based upon the storage class and the region that you are selecting. So imagine that you are using S3 standard. So S3 has a lot of variants. So imagine that I'm using S3 standard one. Then the storage price would be applicable for per GB per month. So there are some charges which I do not remember, but it is very less. I think it is $0.02, $0.02 for 1 GB for 1 month. That is what I remember very vaguely, but I might have to check that. Okay. So like in simple words, it is around 200 rupees per month for 1 GB of the data. So now you multiply that with 2048 GB, because you have 2 TB of the data. So it comes out to be, somewhere I think close to 4,000 bucks, 4,000 Indian rupees. That's what, like, if you do a very rough mental mathematic calculation. Okay. So to answer your question, once you upload the data file to the S3, no charges because incoming data is free. Now, when you store the data file into the S3, you would be charged on the basis of per GB per month rate, depending upon the tier that you are using, depending upon the storage class that you are using of the S3. Imagine that you are using S3 standard. I vaguely remember the charges is around $0.02 US per month per GB. Therefore, with this calculation, your data, you have 2 terabytes of the file, it comes out to be around $47 per month, around somewhere close to, which converts to 2000 rupees approximately. Similarly, if you access the infrequent access, so there is another S3 storage class which is called as S3 infrequent access. I think there the charges would be exactly half. It would be around 2000 rupees per month. For the storage, I'm talking. Similarly, you also have the S3 Glacier, which I'm going to talk about. The charges here would be 1/5. So it would be very less. It would be somewhere close to some suggest 700, 800 rupees per month per GB, per 2 terabytes overall. Okay.
I have a one follow-up question that so 2 TB of data will be divided into smaller chunks of files and it will be stored in the S3, right, sir?
No, 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 no. The after uploading, all the parts are uploaded
Okay.
after the all the parts are uploaded, S3 would assemble them into a single 2 terabytes object file. That is the main difference here. It is a single object is being stored. That is why
Yes,
S3 is single blocks. It is not the block storage. It is a object storage. So
object
what
storage.
2 terabyte file would be joined together, would be combined together to form one single object. While
Okay.
uploading, it would be breaked into the multiple parts. That is called multi-part upload. That is what I was explaining. So do not get confused here.
Okay, sir.
After the uploading is done successfully for all the parts, S3 is responsibility to assemble them into the single 2 terabyte file.
Okay, sir. Cleared my doubt.
Now, if you do some data transfer out, for example, you're downloading the file from the S3 over the internet, there would also be some charges over there. Now, if you're transferring the data cross region, then also there would be some charges. But as I mentioned, if you upload the data, this is absolutely free. You only pay for storage and downloads. So if you store 2 terabytes of the data continuously for a single month in the S3 standard, it would be 48,747, whatever like that number was I just calculated, dollars per month you would have to give. Okay.
Okay, sir.
Any other doubts, guys?
Sir, I have a question. How is this splitting and reassembly done in the S3? Means how on what basis is it done?
You're talking about the multi-part file?
Yes, yes.
Okay, good question. So imagine that you have a very big file. Now, very big file is, say, suppose you have the 2 terabytes of the file. Okay. 2 terabytes of the file. Now, you want to upload this file to the S3. So now you would first tell the S3 that you want to start a multi-part upload. So you would use some API. So basically AWS has the APIs. Using the terminal, you can do AWS S3 API, create multi-part upload. That is what I remember. So you can just upload that to your bucket. What would happen? you would get an upload ID. Now, your SDK or your CLI would automatically divide the file into the parts. So here the file size was 2 terabytes. So each part would be somewhere close to 5 MB to 5 GB, whatever like. The commonly used is 100 MB. So its chunk of 100 MB would be created. So your 2 terabyte file would be divided into, say suppose, 20,000 parts of 100 MB each. Okay. So you have 20,000 parts, part 1, part 2, part 3, part 20,000 like that. Every part is 100 MB. Now each part is uploaded independently to the AWS S3. We do not run this command of manually uploading the parts. Please understand this. It is done automatically by the AWS ACLI or SDK internally. But I'm explaining you dividing and uploading in the parts is done by the SDK, because SDK opens the multiple threads automatically and it would upload the files to the S3. Why is it done? For the high performance, as I mentioned, okay, for the high speed, just to optimize the speed. After all the parts are finished, your S3 would then stitch everything together at the server side into a single 2 terabyte object. And if some upload fails halfway, then the cleanup would be happening, and you would have to, the S3 would have to clean up the entire thing, and then of course you don't pay anything for the unused storage. So as I mentioned, there are SDKs. For example, in the Python, you have the Boto3 SDK. You just upload the file. That's all. S3.upload file. That's what you use. The upload file SDK function would automatically switch to the multi-part upload file if the file is greater. And it would automatically try to break the file into the multiple parts, upload it to S3, then stitching it together, and then forming it one single object. Is it clear?
Yes, sir. But one follow-up question. So if say suppose one part fails or one chunk of that part fails, then is it automatically retried?
Very good question. So imagine that you have 20,000 chunks to be uploaded. Okay. And say suppose chunk number 593 failed. Maybe that because of a network issue, timeout, or whatever, like the temporary AWS service stopped. I think can happen, right? So the multi-part upload would remain incomplete. S3 would not discard the successfully uploaded parts so far. Only the failed part is missing, which is, as I mentioned, 593th part was missing. So what the SDK would do, it would automatically retry that part. It is a responsibility of again SDK, like Python, Boto3 or Java, whatever like you're using. They have the built-in try logic, built-in retry logic with exponential backoff and jitter. That is like the strategy they have. Only the uploaded parts would be re-uploaded and others would be unaffected. The upload continues normally once the failed part also gets uploaded successfully to the S3.
Got
But
it,
in
sir.
case, like the failed part cannot be retrieved or recovered, then of course the entire upload would be aborted.
Got it. That clears it. Thank you.
Okay, thank you. Any other question on this? Okay. Now moving on to the next one, which is EFS. It stands for the Elastic File Store. It's an extension to the network file store system where you have a network storage which is attached to your instance. So what you have to do here is that you cannot have it as a boot volume, which we have already seen. So you can create the instance by using the boot volume from the EBS, and then you can create an EFS and then mount this particular EFS from the instance that you have created. That's how it becomes a separate volume in your instance. And now you can use it. Okay. Finally, S3 Glacier. Glacier is also from the storage class itself, as I was just explaining. Mostly it is used for the data archiving. That is, for example, you have some data which is not in use for the long time. Then you can archive the data and save it into the Glacier. It provides durability, but there is no great throughput for this. There is no reduced latency and all. Retrieval time may range from few minutes to even hours, as well as depending upon how bulk of the data is being retrieved from it. Of course, it supports encryption as well as the data protection. You can use TLS and SSL for the data being uploaded over there. As I mentioned, these are some of the use cases of the Glacier. For the media asset archival, for the healthcare information archival, scientific data archival. It can also be considered as a replacement for the magnetic tape. Also, as you can see here, first you store the data into the S3, and after 30 days, you can store it into the Glacier. And after 5 years, you can delete the data. Thus, Glacier gives you archival capabilities of the data. Okay. All right. So now we will proceed ahead with the next part of this lecture. The databases. So how many of you know about the databases, guys? How many of you have worked with the databases? Can you raise some hands? All right. Which all databases you guys have used? Can you just write it in the chat window? Hmm. All right, good. Thank you, everyone. So let's start to learn about some databases part. So guys, I would like to cover about the Cosmos DB in today's lecture. It's a NoSQL kind of database. Let me share my screen, okay? So first we'll cover up some concepts, and then if the time permits, then we will learn about the demo also. Is everybody can see my screen? Can you just confirm everybody can see my screen, right?
Yes, sir.
Okay. So whenever we talk about the Cosmos, we are talking about this is basically one of the offerings from the Microsoft. Low latency is one of its features. You have elastic scalability and you have guaranteed SLAs. Okay. That is about the Cosmos basically you have. Now, what are the use cases where you would be using the NoSQL data store? Sorry. Guys, please participate. What are the use cases where you would be using the Cosmos?
Video audio storage.
No. Why would you use the media, video, audio here?
Some key and object store, like
Yes.
key and JSON.
So, for example, like you have a massive, e-commerce platform data. Okay, we will take the examples. For example, like you have, you have to build the functionality of something like product catalog. Okay, you have to build, say, suppose some shopping cart. Right? So that is where you use it. For example, you have the IoT telemetry data. So a big data ingestion is happening. Let's say we can use it. We can use it for the financial transactions. Right. So that's where, like, these are the various use cases that you have for the Cosmos DB, where it can be used. Okay. The Cosmos DB has to offer the multimodal support to you. Basically, it supports 5 different data models under one single engine. Okay. Now, the first one is the core, which is SQL API. Guys, whosoever doesn't able to understand, please let me know, okay? We are storing the data in the form of the documents here. And for example, if you are using some microservices or you are building on some of the stuff like that, you can use this kind of data structure. So here the model is the document. Basically, the data is being stored in the form of document. Then you have the MongoDB API. Here also, the data is in the form of the document, and you can use it to patch it with your service. It also provides you the Cassandra API. And the Cassandra, as you know, is the column family, basically. Then you have Gremlin API also, which is basically the data stored in the form of the graph. And lastly, you have the table API also, where somebody just you mentioned, the data is being stored in the form of the key value format. Okay, that's all that you can, different type of the models that you can basically use. Sorry, it basically has 5 data models. That's what like I was mentioning. Now let's talk about important concepts. So the first thing that is very important in this case is you have the concept of accounts. It is basically the top level Cosmos resource. Then you have in the account, you have a database. This is like the logical grouping of the data. Then you have the container, which actually stores the JSON items in the form of graph, document, or rows. And then you have an item, which is an actual record or document as such. Please note here that each container, guys, please understand it very well, okay? I hope all of you are following me. I'm going very slow on this because I want to cover this concept very holistically with all of you.
Yes,
Is
sir.
everybody able to follow me, right?
Yes, sir.
All right, each container can scale independently. In terms of, when I say scalability, basically in terms of the storage or throughput. Now, another concept is partitioning concept. Cosmos DB internally defines the partitions of, basically partitions the data for the scalability. So what do you define? You define a partition key. For example, I'll give you an example. So let's just say here the customer ID is a partition key. Then what the Cosmos is doing is, Cosmos is distributing the items across physical partitions. And each partition can have the own throughput and storage to be taken care of. So far, is there any question? If I go to the examples now. Okay, so if there are no doubts, then let's proceed further. So guys, imagine that you are building a global e-commerce application. Like for example, like you are building like an Amazon kind of stuff. Okay. Of course, Amazon will use Dynamo, but let's try to learn it with an example. Everything would be clear with this. So you have the data available in the various countries, like you have the data coming in the India, USA, Europe, wherever different countries like, right? Each customer would have to have the order status, because if they place an order, they would like to see the order status. And this system needs to be scaled automatically during the sales season, like the Black Friday traffic or something like that. So, okay, this is the need that we are talking about. So here, what would you create? So first of all, you would create, as I mentioned, that Cosmos account. So maybe the name of the company, imagine that. Tell me, anyone name, what is the name of the company you would like to create? Anyone can answer? Okay, just tell me one thing. This is not a technical answer. What is the name of the company you want to launch with the Cosmos DB as the backup store? Guys, come on, just mention any one name. Just wanted to see if you're there with me.
Control S, sir.
Sorry,
Control S.
the name of
It's
the
a
country.
company. Yeah, name of the company is a Control S.
Okay. Let's say we go the name of the company is controllers. Okay. So what would we say? So first of all, we would create an account in the Cosmos DB. The name of the account is that we can create is control S hyphen Cosmos. Okay. Please understand this is the top level Cosmos resource that we have created, where we have created. Then we create a database. The database name would be maybe say suppose retail DB. This is a logical separation to keep the data. And then I would create a container with the name of products. This is like the collection of all the product information, various SKUs that we have, different products that we have on our platform. And then we have an item, which is like a actual product document. This is like an actual record which is there. So for example, the actual record would look like something like a JSON. Okay. So it would have like the ID. So for example, you can have P01 as a product name. The name of the product is, say, suppose I'm taking very simple washing machine. And say suppose the price is, I'm taking very simple 300. I don't know what it is. Okay. So here each record would be stored like this into the container, and each container can scale independently for the performance and storage. Now, as soon as you upload the data into the Cosmos, it would automatically split your data into the physical partitions using the partition key. So here, my ID is the primary key, but I would also like to have one category as the partition key. So for example, this is the electronics. Okay. I can also have P2 like this, which is P02, and the category is apparel. And there can be many other, you know, fields of that. That is not a matter. Then we have the P3, maybe which is like again electronics, and say suppose this is laptop. This is 900. So what would happen is now we have the partition also created. So this is P1. So here I'm also creating my partition key in the form of category. Okay. Now, without partitioning, what would have happened? All the data would be going to the single machine, and it may actually hit up the throughput. Whereas, as soon as I have the partitioning, the data would be divided across the multiple partitions. So all the data belonging to electronics category, because partition key is the category here, would be storing into one partition, and all the data belonging to the other partition would be stored in the another partition. Is it clear?
Sir, one quick question here. With the help of partition key only, data will be segregated as a containers,
Good question.
isn't it?
What we are saying is that all the data belonging to a particular partition, which is say suppose the category here is the partition. So here this is electronics is one partition, then apparel is another category that we have, right? So imagine like let me take one more example. Say suppose I have T4, and say suppose this is like I have the blender, and here the category is home appliances. Price doesn't matter. So what I'm trying to say here is that when you create a container in the Cosmos DB, you have to define the partition key. And here I have defined the partition key for this container as the slash category. The Cosmos DB, what would it do is it will take the value of this key and it would map it to some physical partition. So it can happen that all the records, it would happen like this, that all the records which are belonging to a particular partition would land into one single physical partition. So all the items with a category as electronics would be going to the partition A, Whereas all the items belonging to, all the records belonging to the partition as a parallel would go to one partition B, and so on. So without partitioning, all the data would have been stored on the one single physical machine, with, and therefore you cannot scale it beyond the node's hardware limits. Whereas with the partitioning, the Cosmos DB is spreading the data across the multiple physical partitions, multiple physical servers, and each partition can independently handle and write the request in the parallel. Now, it can also happen that you can have too many requests coming to the same logical partition, like the electronics can have a lot of different products. Therefore, this partition may get hot. Therefore, you would have to use some better partition keys so that the data is evenly distributed. For example, some people use product ID itself as the partition key. In that case, the data would be evenly distributed. Or you can have like the composite key also. Is it clear? Does it answer your question?
Yes, sir. Sir, along with that, can you please explain the container in the same context? Earlier you said some container, right?
Yes. So a container is nothing but it is like the storage of the data, right? So you use the container to store the data. That is where it is like the logical, uh, it groups the data. It stores the data within it.
Oh, okay, sir.
All right. So the next thing in this case, I would like to introduce you to the concept of request units. So RU is a performance currency in the Cosmos DB. When I say performance currency, you would abstract out the cost for reading, writing, query, database operation. And you do not need to worry about any underlying CPU, IOPS, or memory. Okay. So RU basically what does it? It stands for the request unit. And in short, it is a performance currency. Now, you can say it is an abstraction over the read, writes, queries, database operations, etc. Okay. So you don't need to really bother about the underlying CPU, IOPS, or memory. Consider the RUs as like the tokens that each operation is consuming. Cosmos DB would throttle the operation if you exceed your provision RUs. So now, what is the need of the RU? So whatever operation that you do, my dear friends, into the Cosmos DB would require some compute, storage, and network, right? So each operation, for example, you have like the read, write, or query would need some sort of compute, right? I hope all of you agree, right? If you have any question, please raise. Please just interrupt in the between, guys. Okay, I'm going very slow on this because this is a very important concept of the databases. So each operation would need some compute, storage, and network. I hope all of you agree. Now, instead of charging in the hardware terms, Cosmos DB would use RU to unify all of these hosts. Okay. So what can be an example? For example, if you're just doing a simple get by ID, it might just cost you just one RU. On the other hand, if you have like a complex join query across millions of records, it might cost you 5,000 RUs also. Okay. When you perform a write operation, like an insert operation, delete operation, update operation, you would have 5 RUs. You can have maybe 10 RUs. You can have 12 RUs, whatever like that, right? If you are performing a query, it depends upon the number of items scanned, and it can increase if no indexing is being used. If you're running some scanning some large container, for example, you are doing select star from this where, and you do not have like a partitioning close on that, then it can actually end up turning out thousands of RUs for you. Now there are two varieties of provisioning the Cosmos: provisioned versus serverless. So what happened is provision throughput, you reserve certain RUs in the beginning itself at container level or the database level also. So you can serve maybe, for example, like up to 500 RUs per second before you get throttled. That is how you basically do it. Then you also do serverless. Serverless, you do not reserve any RUs. Here you pay per operation. So if you have unpredictable loads, it is good. Is it clear? Guys, is it clear? Can I get some yes, no, yes, no? Okay. Let's take some examples. So imagine I'll take a very simple example. You have ID, name, category. Say suppose you have P01. You have the product name as TV, and you have category as electronics. So suppose you have P02 and you have shirt, and say suppose the category is apparel. Okay. Now you have to answer me, okay, guys? So now you're doing the operation on P01 by ID plus partition key. How many RUs would be consumed? Tell me. Come on. Just answer whatever you know you have understood. How many RUs would be consumed? Don't hesitate, guys. Just answer yourself, unmute yourself and speak up.
One, I guess.
Very nice. One RU would be consumed, right? Now, say suppose you're inserting new item. And the new item is like this, P03. Then you are inserting laptop and electronics category. So you are performing a write operation, right? So it may so happen that it may turn out to be 5 RUs. So you're doing a read, which would have some cost. The cost is 1 RU. Now you do not know anything other than this. For you, RU is the abstraction over the reads, writes, queries, database operation, and it is a performance currency. You're inserting new item, you would have the write operation like the 5 RUs. Now you would perform some query again. So you do like select star from products, where category is equal to electronics. So that is my query that I have. So now tell me how much RUs it would be consumed. So let me just put it the state here. So now you have P03 also. And since you just inserted laptop, you have electronics here, right? Now tell me, if I fire this query, what would be the RUs consumed? What do you think? This is also my query, right?
Maybe 3, sir.
No. So it would, because you are firing the query with having the category as the electronics, and category is your partition
2,
key.
sir.
Yes. 2 RUs would be fired. Okay. Now imagine, guys, you run 100 reads by ID. Now the data has grown up very big. So, and you're reading 100 by reads by ID. So it would have 100 RUs, right? Say suppose you're also you're also performing 50 writes. So now, as I mentioned, one write operation is taking the 5 RUs. So 50 RUs, if you're performing, it would be taking 550 RUs. So what is the total? 350 RUs, right? And this is per second. So guys, what I'm talking is that per second, let me just clarify, per second, following operations are happening. Okay. Now, as I mentioned to you earlier, that you configure that we configure the throughput, provision throughput. So imagine that I'm working in, so this is like just the serverless mode. Now, I told you, right, there are two modes, provision and serverless modes. So imagine that this is the provision mode. And I have configured it with 500 RUs because I have to specify per, per second. Okay. So I have configured the RUs per second, first of all, and then following operations are happening. So this is like, say, suppose 200 reads are happening and 100 writes are happening. So 200 reads would be 200 RUs per second. This is happening simultaneously, guys. Simultaneously. And 100 writes would be how much? Tell me. Guys, come on यार, मतलब attentive नहीं हो क्या
500
क्लास में? 500 सिंपल. मतलब एक राइट अभी हमने देखा ना ऊपर. One write is taking 5 RUs, so 500 RUs for the 100 writes. Right. So what would be the total? 700 RUs. और
700.
हमने configure कितने पे किया था? 500 RUs only. Since my usage is getting beyond the 700 RUs, because my operation count has exceeded the 500 RUs per second as the limit, therefore, the Cosmos DB would return 429 too many requests. Basically, it is going to throttle. Result, throttling would happen. And throttling status code is 429. That is too many requests. Is it clear?
Yes.
Yes, sir.
Tell me if anybody of you have any doubts here. That's all about your Cosmos DB, guys.
So, sir, what are the ways to handle the throttling here? Is it only way to increase the provision?
Yes, the only way is to increase the provision throughput. Okay, so let's go ahead and let's see some demos. All of you can see my screen.
Yes, sir.
So let me take you to Cosmos. So this is my Cosmos DB homepage. Okay. So what you can do, you can go, I just search for Cosmos and you would find your Azure Cosmos DB. And as of now, I do not have any account created. First of all, I'll create an Cosmos DB account. Now I'll have to choose the API. As I just mentioned to you, I have API for NoSQL, MongoDB, table, Postgres is new thing that they've come up with, Gremlin, Cassandra, NoSQL, and MongoDB. Okay. So I can choose any one model depending upon my need, depending upon what I'm going ahead with. Okay. So let's go ahead with NoSQL. Cool. Now, what is the workload type I want to use for production? I'll have to choose a subscription. I'm creating one new resource group, maybe Aditya resource group Cosmos. Okay, this is my resource group. Now I'll have to specify the account name, guys. So as I was mentioning, control as somebody told, control as Cosmos. That is the name of the account that I've created. And you can make it a little more readable. So you can have post control as Cosmos, NoSQL store, right? Like that. Okay. And then you can have the provisioned throughput. So I can choose the location also. Let's choose Asia Pacific, maybe whatever, like Indonesia Central. So that's where, guys, I have the two capacity modes, provision throughput and serverless. In the provision throughput, your RUs you have to predefine, and it would have the auto scale also mode configured. Whereas in the serverless, it is just that the serverless. You can just use anything that you want, and you don't have any prediction about it. Now, in the case of we are going with the provision throughput. With Azure Cosmos free tier, you will get first 1000 RUs as free and 25 GB of storage for free in the account. You can enable free tier like that. So if I don't want to enable, I can just also do not apply. If I want, I can enable it. Next, I would say, okay, this is the redundancy and multi-region right. I'll just keep it by default. You're also giving me the backup options. Backup I want to do periodically. What should be the interval and the retention of the backup? Well, whether I want LRS or ZRS. Data encryption, whether I want the CMK, the customer managed key or service managed key. I can give some tags, and finally I have the validation is passed. And if I go back, so I can just see in the serverless, you will not have all of that. In the provision, it will just have some options for you. Finally, I hit the create button. So the deployment is happening. We'll wait for the deployment to finish, guys. Somehow it is taking some time, guys. Let it happen and let's see if it succeeds really. All right. So our deployment has been created, guys. Now what I'll go to the Data Explorer. I hope all of you are following with me, right? And I will just create on overview add container. Guys, here you see add container. So now I have created in Cosmos account. Inside the Cosmos account, I'm launching the new container. So you see, first of all, as I mentioned to you, we'll have to create a database. So let's create the database. So my database here is the products DB. Okay, because I wanted to keep the information about the products database. And here you can see, guys, I can specify the container. This is the unique identifier for the container that I'm going to use. Okay. So my container is the products because I'm going to hold the information about my products. Now, partition key, as I mentioned to you, I'm going to choose slash category. So let's use this. Now, as I mentioned to you guys, there are two types of the modes available: container throughput auto scale and manual. Because I'm using the provisioned one. This Cosmos account level I have created, Cosmos account level I have created the provisioned one. If I would have selected serverless, then this option would not have come to me. Now, since I selected the provision, it is asking me there are two modes in the provision: auto scale or manual. Auto scale would allow you to scale from minimum to the maximum RUs. So minimum it will charge for 100 and maximum it will take you to 1000. If I want to keep 400, then you can see the minimum goes to the 400 and maximum goes to the 400. Minimum goes to 40, sorry, and maximum RUs can go to the 400. And it is also showing me the estimated monthly cost because the charges are basically for per RU. So I'm going ahead with 5400 for now. This is not needed. And I'm going ahead with, okay, it's asking minimum is 1000. So let's go with minimum 1000. So maximum RU's minimum value is 1000. So minimum RU's is 100. Minimum I'll have to pay the charges for 100 RU's, even if my load is not per second like that much. And maximum I can touch to 1000 RU's per second. So I'm creating a new database now. And inside the database, I'm also creating a new container with the name of product. So far, I hope it is clear. I created a Cosmos DB account with the name as control S Cosmos NoSQL store. Inside this company's, I have created one new Cosmos DB account with the name of products DB, and products DB has one container called as products. Now, the items is nothing but it is the record. Like for example, just say in the table you have, so consider a product container as a table, and table has many items. Table can have many records like that. I want to insert a new item. So let's do new item. I clicked upon this new item. I'm copying it from there as we saw. So imagine that this is P0101. Name is TV, category is electronics. And now I do save. If you see, this is what a new record has been inserted into my Cosmos DB container. Is it clear or not so far? Guys, can you speak up? Some yes, no? Nobody speaking. Is it clear or not?
Yes, sir.
Okay.
Am I audible?
Yes, you're audible.
Yeah, sir. Container inside a container, a kind of a entity goes, or a kind of mixed items also can be. Like here we have in this example only products we have created, right?
Sure. One sec. So you see, I have also inserted in another item now inside this particular container.
Okay, electronics.
So the first partition key was electronics, second partition key is apparel.
Okay.
So I can have n number of keys inside my n number of items inside my one single container. Items is nothing but it is one record. Like the database, you insert one table, the one record. Similarly, you have one record over here.
But the JSON schema needs to be same inside a container, one single container. Is it like that?
You're asking for all the items in one container?
Yes. They have to adhere to same schema. The JSON that right side I'm seeing ID, name, category, price.
That's a very good question, I would say, first of all. Let me explain it. So Cosmos DB is a schema less. Okay. The JSON document in the same container that I'm inserting, they can be of the different schema also. They do not need to have the same schema. The answer is this.
Okay.
Now, only two things which matter for the uniqueness mostly is the ID and partition key. ID is unique within a partition, and partition key will basically is where something which where all the documents must have the partition key field defined. Okay. So for example, like let me demonstrate it. Okay. So imagine that you are inserting like one object, and that particular object is like a TV. So it would have some dimensions like breadth, maybe like width and height, isn't it? And it would also have the attributes like what is the warranty of it, like 2 years. Then you would also like to store in the real time cases what is the stock quantity that you have for it, isn't it? Correct?
Yes.
But in the case of the shirt, you would like to not store width and height. आप उस केस में you store करोगे कि what is the size of it? Maybe L, M, XL, whatever like this, isn't it? Similarly, in the case of the jeans, you would have the size as 32. Size is not like that, right? And then you may have the color also there. So let's do that. So imagine that you are doing a full-fledged thing. So you would have the dimensions like, now please note that dimensions is one additional schema field that I'm having here. And I would not have the dimensions in the case of when I'm doing the shirt. Okay. Let's try to insert it. Great. Expect it. Because this ID already exists in my same contain and this my category is the electronics. So I cannot allow me because within a single partition, which is the category here, ID has to be unique. So let's insert like this 102. Cool. Hit insert. Now I want to store maybe another item which is belonging to apparel, and here the size is M. It doesn't have the dimensions, guys. Okay. Yeah, this is also saved. So what you asked, I demonstrated that two documents or two items in a single container can have different schema also.
Okay.
Now you can also have a third type of document also. For example, tomorrow you say that, okay, this is Diwali and we want to give the discounting. So great. The category needs to be same. Yeah, you can save that. There is absolutely no, schema of like the product like that.
Yeah. So the partitioning reference column or that tag should be same across all the different documents.
Yes. So now I can just discard. Now I can just type the query here. So you see, this is how I can query. So I can just do where, and then I want C dot category. I want this to be electronics. Yeah. See, I got 3 row codes.
So can it query on outside of the partitioning column anything which is
Sorry,
unique to
come
it?
again.
Can it query on some column which is not common across all the documents? Say discount.
Yeah, this count has also come in here. Yes.
So can I query you in the where clause with discount?
Yes, you can do that.
Okay, then
But
it's great.
what do you think? What would happen?
That's what I'm thinking. Yeah, because in the RDMS, like it has a fixed set of schema, right? Here, every entity can have a different structure. So I was wondering, will it be able to query that or not?
Yeah, let me go structurally. Okay, this is a very important question you have asked. So this is my first query that guys I have showcased. So you can query on the electronics. So it is selecting all the items in a specific category. The category here is our partition key. So please note here the syntax. The C is the alias here that I am using. And C is an alias for each document in the container basically. And it would return me all my documents present, all my items present in the electronics category. Okay. Now, the next thing, if I want to select only the specific fields, say suppose I want only ID and name, then I can do that also. And I can just, type that. The another thing that I wanted to show you, for example, now you want to do that, okay, I want to have only those items for which the price is greater than 100. I can just apply that and I'll get two documents. You see, TV and this is also another TV I have. So you got me two documents which has price greater than 100. Now I want those documents for which my stock count is greater than, say, suppose 50. Sorry. So it gives me those documents for which I have the stock greater than 50. Now I want to order the results that I can also do. So I can do C dot category is equal to electronics. I'm just showing you some examples that you can use in your daily life. Order by C dot price, right? And then you can do maybe descending or ascending, whatever like you want. So it gives me in the form of that. Now it also gives me this particular thing, but it doesn't have the C dot price. So I can just have, uh, I can handle the missing field also, but that is something that I can also do. Here, I can also do maybe another query I'm going to show you that C dot price is less than 500. It would show me. So I can show you that, okay, these are two records for which my price is less than 500. Because the query I'm firing on the category and the category is the partition key. Therefore, Cosmos DB will only query that partition. Therefore, it is faster and cheaper and it would have less RU. So if you do not include the partition key in your queries, it would do a cross partition query. And the cross partition query can consume more RUs. Now, I'll come to the question which is asked by one of the gentlemen, which is C dot discount, right? So C dot discount maybe is greater than 5. It just gives me one product. Now, please note here, I have not specified the partition key, which is my category. Therefore, this query is happening across the multiple partitions. Okay. Anyways, So the point that I'm trying to drive here is that this particular operation is going to consume a lot of RUs. Why? Because this query is using the multiple querying over the multiple partitions, because I have not specified the category is the electronics or category is the apparel or something like that. So the long story short, you can, and this query can be, slow also. So the long story short, you can query any JSON field in the Cosmos DB, even if it is, if it not all the documents may have it. But the querying on the partition key would be more efficient and would be more cost friendly because of the single partition query that it happens. If I do select star from C, बहुत heavy query है ये. This is very heavy and very costly query because it is giving me all the data across my all the partitions, across my all the records. Okay. Okay, so that's all that I wanted to showcase to you. And there are some more things that you can do. You can see alerts and metrics and the data also that you can evaluate yourself. But I think that's what I wanted to show you. So I hope you understood it. You liked this particular lecture. If you have any questions, please feel free to ask me.
Sir, at what scenarios Cosmos DB will be utilized or used?
Sorry?
At what scenarios we are using the Cosmos database?
So as I answered earlier, as I just mentioned in the beginning itself, you can use the Cosmos DB for a lot of scenarios. For example, you can do it for the real-time skin applications, like you have the live dashboards, IoT telemetry for ingestion. You are collecting a lot of data from the different sensors. You are having e-commerce product recommendations, content personalization, a lot of such varieties. Gaming, e-commerce, banking, transactional data, lot of places you can use the Cosmos DB.
Okay, sir.
Okay. All right. Then thank you everybody. And I wish you a happy Diwali to everyone. I hope you liked it, and kindly let me know if you have any queries on the chat window. Thank you.
Thank you, sir. Wish you happy Diwali.
You
Happy
too.
Diwali.
Thank you all.
Thank you. Thank you.
Thank you, sir. Happy
Thank
Diwali.
you.